is connected across source of variable voltage and the voltage is gradually increased. The fuse blows out when the voltage reading of the voltmeter and ammeter. So just when the drop across the fuse is 1 volt and 1 ampere, it will blow out. There is a maximum permitted value across the fuse. So what is the maximum permitted value of voltage across the fuse? If there's a fuse, the maximum permitted is 1 volt and the maximum current is 1 ampere. Anything more than that, that ammeter voltmeter, they'll indicate the voltage. That's all. You need not to bother much. The circuit. So I'm helping you with this information here. If the voltage across the fuse more than 1 volt, it will burn out. If the current through the fuse more than 1 ampere, it will burn out. So the experiment is repeated with another fuse F2 and the reading of voltmeter and ammeter when it blows out is 2.4 and 1.2 ammeter. There are 2 fuses are there. So there's a fuse 1. What about fuse 2? I'll write 1, 2 like this as symbols. I2 is how much? 1.2 ampere. Anything more than 1.2 ampere, it will burn out. V2 2.4 volt. Okay, keep like this. So now these fuses, they are connected parallel. Now it's asking what conditions will arise. Straight away, I think you can. So there's a maximum permitted voltage, 1 volt, 2.5 volt. So which fuse will first burn out when their series parallel is asking. See now, don't get confused. So suddenly fuse came. I don't know what to think. You treat this is like a calculate the resistance. What is the resistance of this? V by like a V1 by I1 will be the resistance of the fuse. Similarly, what is the resistance of this fuse? V2 by I2. So bring them, those two resistance, and you have this particular cell, you're going to increase. So check now, as you keep on increase voltage, first, which particular fuse will burn out? Treat fuse as resistance. Sir, how we don't know resistance. I think he has given that maximum voltage current. No, with that you can bring the resistance of fuses. What is the resistance of this fuse? R1. 1 by 1, 1 ohm. What is the resistance of this second fuse? V2 by I2. We don't have much information in the book regarding the fuse. Only thing is voltage greater than that, it will burn out. So possibility, there can be a numerical also, this one. Okay, now come for this one. This is resistance R1. This is resistance R2. Now you make it the problem of simple series parallel and you are going to increase the voltage. Tell me, looking at this, R1 less than R2, no? As you keep on increase voltage, across which fuse, both will have same voltages. But tell me like across which fuse the current will increase more. I think you are, I'm writing I2. This is I1. This capital I1, small I1 are different. I1, I2 are the voltage, the current that are flowing through the fuse when I'm increasing the voltage in the second diagram. Okay, looking at this, we have R1 less than R2, no? So then the current and any information of currents, I'm discussing for second diagram.
I1 greater than I2.
I1 greater than I2. As I keep on increase the EMF, E. So current in which particular fuse will increase more? I1, no? So which fuse will first burn out? Which fuse will first burn out? So both are having same voltage rating. But look at I1, maximum current of I1 is less than that of I2, no? You can see here. So if say, let's say current in the first fuse is say 1.1 ampere. In the second fuse, how much it will be? Because I1 greater than I2. If let's assume that if I1 equal to 1.1 ampere. So what do you expect I2? I2 will be say 1 ampere or 0.9 ampere. Still, this second fuse is safer side, no? Whereas this will burn out. Find the reading of emitter when any one of the fuses blows out. So which fuse first will blow out? The first fuse will blow out. So as voltage, as the EMF of cell is increased, so the fuse 1 will first burn out. If the fuse 1 burns out, then what conditions will come here? No, only fuse burns out. What will happen to fuse after burning out? So how the circuit will be? There's a fuse F2. Okay, this will be the state of this one. No, the fuse 1. So what will be the reading of voltmeter? The reading of voltmeter will be the applied EMF. So now for the fuse 1 to burn out, what should be the current it should pass? How much it should pass? 1 ampere current should have been flowing, If there's 1 ampere and we know resistance, how much? 1 volt. Then what should have been the applied voltage here? 1 volt. Are you able to analyze? See, we don't have any formula. We have to check it for this fuse F1 to burn out. So what is the current needed? 1 ampere. For 1 ampere, and what is the resistance of?
Low.
For the fuse F1 to burn out, what should be the current? 1 ampere. Then what is the resistance of the fuse 1? 1 ohm. So what should have been the applied voltage? Should be 1 volt. That 1 volt will drop here. So what should be the voltage drop across the fuse? F2 will be V2 should be equal to 1 volt. And what is the current through it? You calculate current 0.5 ampere. Is it safe? Yes. Able to analyze the method? After burning out the fuse, you have to replace with an open circuit. Burns out, replace fuse 1 with open circuit. Okay, now similarly, come for if they are in series. Can you work out the series one? I'll proceed to the next concept. You try the second part.